Here is very important theorem. The statement of theorem says prove that under root 2 is an irrational number. Do you remember the irrational numbers? The numbers which are surds and indices, and you see the decimal expansion which are not repeating and terminating. Those numbers are called irrational numbers. We know that this root 2 is an irrational number, but how can we prove it? Let me try to make you understand the proof of this theorem. First, let under root 2 is a rational number. On the contrary, rational number on the contrary, we let under root 2 is a rational number. So under root 2 must be equals to p by q, where q is not equals to 0. P and q are integers, and very important result we will use here, that HCF of these two numbers, the p and q, equals to 1. This means both these numbers p and q have no common factor other than 1. Now we shall cross multiply these two numbers. We get p equals to under root 2q, and squaring these numbers, squaring both sides, we get p square equals to 2q square. And what we observe here, we see that the value of p square is 2q square. We observe here that the value of p square equals to 2q square. So therefore p square is divisible by 2. Therefore p is also divisible by 2 by the theorem 1.3. Now we let this equation is equation number 1. We observe therefore 2 is a factor of p. Now we shall put p equals to 2c in equation 1, and when we put to p equals to 2c in equation 1, we get 2q square equals to 2p square, and we get 4p square. 2q square equals to 4p square. Cancelling to both the sides, we get q square equals to 2p square. Now what we observe now, we observe that the value of q square equals to 2p square. So q square is divisible by 2. So by the previous theorem, q is also divisible by 2. And what we see now, we see so 2 is a factor of q. Therefore this is very important here, 2 is a common factor of both p and q, but this contradicts the fact that p and q have no common factor other than 1. Therefore, this contradiction is because of our assumption that under root 2 is a rational number. Our assumption is wrong. This leads implies that under root 2 is an irrational number. This is the proof.